Welcome back. Generative AI catches our eyes. We said that machines are getting intelligent, but this looks like creativity. How does it work? How can you run it in detail, step by step? OpenVINO has few ready notebooks that can help you run Stable Diffusion right away. Let me show you in a minute. At the basis of our ability to perform generative AI and manipulate or generate images is our ability to represent an image in its features or latent space and able to convert it back to the pixel space. The first layers of neural networks like VGG16 and others are built to extract features of the image and by that create a representation of the image in the feature or latent space. And here is a nice example to get some intuition. I took a very small data set, shirts and shoes, and trained a model to extract their features. There's a nice video explaining this. I'll leave you that link. You can see here for simplicity just two-dimensional latent space on the left. Using these only two features or dimensions, I can represent and of course distinguish between the shirts and the shoes. Each blue point on the left represents one of the dataset images. For example, this point corresponds to this red shirt, this point to this black shirt. There's no dataset point, no image in between them, but if we render this point in the middle, we'll get something between these two shirts. The total opposite side of the latent space represents a white shoe, and the more we go up and to the right, we'll get images closer to shirts and darker. So we can extract the features of objects and a combination of these features, what we usually choose using a feature map is that object. For example, a cat and a dog both have the feature 4 legs, for example, and the feature a tail, and so on. So they will be located close to each other on the feature or latent space. A chair also have 4 legs, so it will be closer to them than a boat. Again, just to demonstrate the concept. On the other hand is the text. We break it into pieces we call tokens. And here is a token for a cat, and here is a token for a dog. And we can map these tokens to an embedding space, the latent space for words, if you like. And here too, I envision that a dog will be closer to a cat than to a chair. If we can map the embedding space to the image latent space, we basically know how to represent the text in the latent space. So if you tell me to draw a cat, I know how the latent space of a cat looks like. All I have to do is go back to the pixel space and you have a cat. And how about a cat sitting on a chair? Can we just add the features of the cat and the features of the chair? What operations are legal at the latent space? And how can we get a smooth images out of this? Well, this is the magic. We start with a noisy image and we use an iterative process of removing the noise. We use a UNet model for that, basically downsampling, which smoothens the image, and upsampling again. You'll find many more details online. And we use this model to predict the noise conditioned or associated with our prompt embedding, and then remove that specific noise. This is all done in the latent space, so faster execution. And when done, we can use the autoencoder to get our image result back in the pixel space. To see that in action, just navigate to the OpenVINO notebooks. There are several related notebooks. Please note that you will need a machine with large memory. If you just want to run Stable Diffusion, you can use notebook 236. This is probably the easiest way, and probably the minimal required code. Plus, it's optimized using Optimum Intel. Let's download the models, save them and compile, prompt, run, and I can paint like Van Gogh. And there are many other related notebooks for image, inpainting, and more. Notebook 225 is an opportunity to get more details. Make sure you have enough memory and the right software versions. First things to do is to get the pipeline and the 3 models from Hugging Face. The text and code from prompt to embedding, the unit model for the noise reduction and the diffusion process, and the autoencoder to bring us back from the latent space to the pixels. And now we'll convert each of the models to OpenVINO format. As a nice thing is that you can find these models here in the files and explore them. And now, OpenVINO core object, load and compile the 3 models, and here is the OpenVINO Stable Diffusion pipeline with all the models and the components that we already have. And now we can look inside. For example, check how the tokens for cat looks like, or the tokens for any prompt. And we can even see the embedding space. It doesn't tell me much, but there are some ways to visualize them if you want. And let's run. Text to image, choose the prompt and other parameters, run the pipeline, generate the image, and present it. Pretty cool. And you can also run the image to image generation. And that's all. Text to image or image to image generation step by step with OpenVINO notebooks. Enjoy, subscribe. Thank you.